Sometimes we're going to want to talk about present value. Present value there's two ways of looking at it. One is the amount of money you would need to have today to have a certain amount of value in the future, or it's how much some future money is worth today. So for example, if I'm offering you $20 a year from now, that's the present value of that is not $20. You're not going to give me $20 to get $20 a year from now. You might give me maybe $18 or something. So the present value of a future $20 is only 18. Or to put it another way, the $18 is what I would have to invest right now to get $20 in the future. If you understood that, great. If you didn't, we're going to do it like with math and formulas. So we have our usual compound interest formula, and we're going to rearrange it. So what we're going to do is we are going to divide both sides by 1 plus I to the n. Chink, chink. And so we're going to get a over 1 plus I to the power of n equals p. And ta-da, that's all the rearrangements, actually. We're done. So writing it in a more traditional way, I would say that the present value is going to be the future value, kind of the a, divided by 1 plus I to the n. Or, there's the super cool way of writing it. Which is, we could bring, that's the same, I'll just write it out. It'd be 1 plus I to the negative n, because a negative exponent brings that to the bottom of the fraction. And they're both reasonable ways of writing the formula. I'm going to pretty much use this one though, because it's better. Okay. So, you want to have $800 in the bank account at the end of 5 years. How much would you have to invest? Yeah, after I was writing the problem, I realized I should probably say today. But I didn't feel like rewriting the whole problem. How much would you have to invest today at 17% per year, compounded annually, to get that much? And nothing really changes. So we're still going to have our P, A, I, N. So the present value, we don't know. So P is now present value. So it used to be principal. Now it's present value. Conveniently, they both start with a P. The final amount is going to be $800. The interest is 17%, which we write as 0.17. And we want it at the end of 5 years. So n is going to be 5. So what's going to be, we're going to say, okay, P equals A times 1 plus I to the negative n. $800 times 1.17 to the negative 5. So 1.17 to the power of 5 times 800. Make sure you can do this on your calculator. It's easy to watch somebody do it, but typing it in is not necessarily as easy as people might think. 364.8889. And writing that in a nice way, we would need $364.89. So the value of $800 in 5 years, assuming that this kind of a investment is available to us, is only $364 today. Or put another way, if I invested $364 today, I would get $800 in the future. Same idea, you need $16,000 to purchase a new car, a GIC. A GIC is it's a financial instrument, so it means it's something you can invest in. It stands for I think a guaranteed investment certificate. I'm not 100% sure. Essentially, you put your money in, and it's stuck in there, and you can't really take it out. Or you could take it out, but then you lose all the interest. So essentially, you're promising to leave it in there, and it will pay you a higher interest rate. Not necessarily that high, but about high. Okay, so the present value. So how much do we need to put in there to get our car? Well, we don't know. We're trying to figure that out. We do want to have 16,000 though at the end of the day. The interest is going to be 7%, but it's compounded quarterly, so we divide by 4. So that's going to give us 1.75%, which is going to be 0.0175. It's 8 years, and it's 4 compounding periods per year. So it's going to compound 32 times. So, putting it together, P equals A 1 plus I to the minus N, and that's going to be equal to 16,000 times 1.0175 to the power of negative 32. Note, I mean, here I was able to be exact, but when you have big exponents, either keep the fraction and keep all the decimals, or keep a lot of decimals, because rounding there is not necessarily the way to go. Plus 1 to the power of negative 32 times 16,000. So that's going to be 9183.719, which is going to be, so we'll need $9,183.72 today to get the $16,000 8 years from now. One problem with this calculation, of course, is that the car is probably going to cost more than $16,000 8 years from now, because we're going to have inflation issues and things like that. But that's a more complicated calculation, and we're not going to be doing that in this course.